Hey everyone, welcome to my channel and today we will going to discuss about the hemolytic anemia. As the name suggests, the hemolytic anemia. So first we have to know what is the process of hemolysis. Here you can see I have written a definition that going to explain about the hemolysis. That the hemolysis is the destruction of the RBC with the release of the hemoglobin from the RBCs. So, when the RBCs are destroyed earlier than their lifespan, there is a release of hemoglobin from the RBC and there will be a loss of hemoglobin and the blood. That's why causing the hemolytic anemia. That is the condition called as the hemolysis. Coming to the types of anemia, that is the hemolytic anemia, include the hereditary spherocytic anemia, the sickle cell anemia, and the erythroblastosis fetalis anemia. Starting from the hereditary spherocytosis anemia. In this condition, you can see the three important features. That is, the biconcave shape of the RBC is lost, in which the RBC lose their ability to squeeze because this biconcave shape is converted into a circular shape. The spherocytosis means that there is a production of sphere-shaped RBCs in the blood, and that's why because of the deficiency of their biconcave shape, they will not squeeze through the cell membrane and they cannot pass through the bone marrow into the blood. That's why the damage during the diapetesis, the process of diapetesis, damage these RBCs and causing the anemia. And it can be due to the hereditary condition or it can be congenital. Here you can see these are showing the microcytic hypochromatic spherocytes anemia. These are the spherocytes RBCs with the less hemoglobin concentration causing the hereditary spherocytotic anemia. Now coming to the sickle cell anemia. What happens in the sickle cell anemia? It happened because of the faulty beta chain and there's a production of the hemoglobin S. So what is a faulty beta chain? The beta chain is the component of a normal hemoglobin, and when there is a defect in the gene of the beta chain in the hemoglobin S, there is a formation of a different hemoglobin. There is a hemoglobin S and there will be precipitation of this hemoglobin S in the hypoxic condition. When there is a hypoxia or decrease in the oxygen concentration, this hemoglobin S will going to precipitate in the blood as the precipitate and it got causing the damage of the RBCs. In the blood, they cause the damage of RBC and the viscous cycle start by damaging, further damaging, and then the death may occur. Because it caused a decrease in the lifespan of RBCs, that's why this anemia is occur. And why it is called sickle cell anemia? Because there is a shape of the sickle cells. The RBCs become sickle cell and that's why they also cannot squeeze through the cell membranes and they destruct and rupture at the time of diapetesis. That's why causing the hemolytic anemia. Here you can see the sickle cell anemia, how the structure of the shape of the RBC during the sickle cell anemia. These are the sickle cells of the RBC and these are the normal RBC. So this shape of the RBC cannot pass through the diapetesis and cannot carry the normal amount of hemoglobin. That's why causing the hemolytic anemia. Now the last cause causing the hemolytic anemia is the erythroblastosis fetalis. What is the erythroblastosis fetalis? It is a condition of RH incompatibility. In the RH incompatibility, when there is an opposite RH group of a mother and the baby, it will cause the lysis of the RBCs. In the blood, there will be a destruction of the more and more RBC of the fetus. That's why the fetus may abort or it may develop the hemolytic anemia. And there is a more production of the early blasts that are the reticulocytes or before the mature cell. These are the blast cells that causing the increased production. Because of these increased production of these immature cells, there is a destruction of cells in the fetus and this causing the erythroblastosis fetalis. In the fetus it is caused and there is a blast formation. That's why this is called as the erythroblastosis fetalis. Here you can see the condition of the erythroblastosis fetalis, in which there is a production of abnormal size RBCs plus there is a destruction of the RBC. There are less number of RBC and greater number of other cells like WBCs and neutrophils in the blood. That's why there is causing the hemolytic anemia. Now here you can also see that there is a damage of the RBCs and this is showing the normal RBC and this is showing the damaged RBC because the wall of the RBC is going to damage and there is a release of the substance in between the RBCs. This is called as the hemolysis of the RBCs. To treatment of that hemolytic anemia, If the hemolytic anemia is due to the sickle cell anemia, there is a condition called as the blood transfusion is a treatment for the hemolytic hereditary spherocytic anemia or the sickle cell anemia. The blood transfusion is beneficial and it causes the recovery of that anemia. While that in the erythroblastosis fetalis, because the blood transfusion cannot occur at that level because the fetus cannot absorb too much of the blood. That's why there is a condition called as a bone marrow transplant. That is an important treatment can occur in the erythroblastosis fetalis. Or some of the important preventions of the erythroblastosis fetalis, including the injections that are injected before the birth. That's why they prevent the erythroblastosis fetalis anemia. So this was general explanation about the hemolytic anemia and the hemolysis and different types of the hemolytic anemia, including treatments. The symptoms are similarly the same, the causing the fatigueness, the dyspnea, the weakness and the paler skin are the symptoms of all the anemias that include the hemolytic, the megaloblastic, the blood loss, the iron deficiency, all that anemias. I hope you will explained well. Thank you for watching.